Okay, hey guys, here's a quick video on the Desmos activity that I sent to you so that you can kind of have an idea of what I expect you to do. Okay, so as you can see, there are two sliders. This slider changes the angle, which in turn also changes your opposite, adjacent, and hypotenuse. And then there's also this vertex point that helps you to also change the size of the triangle. Okay, one of the things that you have to do is you need to label in this box, you need to enter which one is the hypotenuse, which one is the adjacent, and which one is the opposite side. So for this particular slide, that is what you need to complete. Okay, and what you're investigating is how are the ratios of the sides in similar right triangles related, and you're going to create 5 similar triangles. And you will record their lengths, and you're going to start out by choosing a 30-degree reference angle. Okay, so here's my slider. My reference angle is already at 30 degrees. So as you can see, I already filled out a couple of sides based on changing from dragging this red dot up top of my triangle. Okay, so you will enter those values in these tables that you see here. Then you're gonna hit next. Notice that I have NaN in rows 3, 4, and 5. That's because I did not do all 5 of the trials. And then you're going to set up the ratio opposite over hypotenuse. Okay, so here's my opposite value, 1.62 divided by 3.24. Okay, and you would enter that into a calculator and you're going to round to 3 decimal places. Okay, once you do that, you're going to enter those particular values into this table. Okay, then you're going to tell me what is it that you noticed about the ratios. Okay, don't worry about the class results because that's not something that we can do since we are all doing this in our own homes due to social distancing. Okay, here's the second triangle where your reference angle is 40 degrees and you need to change the sides by dragging the vertex that's up top. And again, you're going to fill out 5 trials. So you would be dragging that vertex up and down and filling out each cell of this table. And you're going to do the calculation again. And remember that the hypotenuse, opposite, and adjacent get populated for you. So all you need to do is do these calculations and enter the values in those three columns. Okay, and then you will say what you notice about those ratios again. And then you're going to investigate the 50-degree reference angle. Okay, so far you would have done 30 degrees, 40 degrees, and now 50-degree reference angle. Okay, and you'll do that again. You know, set up the ratio opposite over hypotenuse, and then you're going to tell me what it is that you notice. Let's see. Okay, and now they're introducing you to this Greek letter theta. In math textbooks, you tend to see this Greek letter theta. It looks like an O with a horizontal line in between. That is used to signify your reference angle. So nothing crazy. It's not out of this world. Instead of saying sine of angle A, you would say the sine of angle theta. Okay? And then they're showing you this trigonometric table. This is the old-fashioned way of figuring out the sine, cosine, and tangent of different angles. back when people didn't have access to computers, cell phones, or even scientific calculators. Okay, and then you're going to go ahead and read the table. So if you were told to find the cosine of the angle that measures 60 degrees, you would find the 60-degree angle and go to the cosine column, and then you would choose that value. Okay, so this is saying that if you have an angle that measures 60 degrees, the ratio would be equal to 0.5. Okay, so here you would try, well, what angle gives me a tangent that's equal to 1? You would go back to your table and go to the tangent, and then you're going to be looking for 1. Well, I see my numbers are increasing here, so that means that the tangent of 1, here it is, it's 45 degrees. So you would type 45 here. Okay, so try your best, and I hope you find this interactive simulator helpful to understand what it is that we're learning in this new section.